We're looking at the Chapter 10 review. This is the chapter that covers circles. We have the unit review, and then following that is worksheet 7, which was included in your packet. So if we look first at number 1, EF and EG are tangents in the circle. So the fact they're tangents, we can make right angles there because tangents are perpendicular to the radius. And that lets us now look at kind of a quadrilateral as we look for angle E. 90, 150, and 90 add up to 330. I subtract that from 360 and I get 30 degrees. Furthermore, just something to look for as you go. If you have a problem where you're looking for either this angle and you know the central angle, or you have this angle and you're looking for the central angle, keep in mind this is going to be a kite with 90 degrees if we're at the tangents, so these two will be supplementary. So that does make it easier, something to at least look for as we go further. So that's our first one, we get 30 degrees. For number 2, we need to see if it is a tangent. We need to find the value of x. Well, again, since it's a tangent, we know that's a right angle. So we use Pythagorean theorem, and we get x squared plus 7 squared equals 7 plus 18 squared, or 25 squared. Now, that gives us x squared plus 49 equals 625. If I subtract 49, I get 576. And then the square root of 576 turns out to be 24. Looks like my pen's losing here. Let me get a different pen. For number 3, we're looking for arc BCD. And that is the arc that starts at B, goes through C, ends at D. First off, I have this central angle here at 144. This arc is also 144, CD. Then I can look at this right half of the circle, which is split by AC, and I know that it's 180 degrees from A to C this way. I already have 34, so I subtract 34 from 180, and that's 146 from B to C, so such that BCD is 146 plus 144, which is 290 degrees. For number 4, I need to find arc LN. Now, I know ML to its inscribed angle, so I can double this angle and get 56. And then I know that MN and LN are the same because their chords are the same. So if I subtract 56 from 360, I get 304, which is the amount left for each of these. They're equal, so 304 divided by 2 is 152, which is each of these. So that is LN 152. Number 5 is an inscribed quadrilateral. Even though I don't know the other angle, the one on the top right, the fact that these two are opposite of each other, I know they are supplementary. So 2x plus 4x equals 180. That gives me 6x equals 180, and x is 30. If I needed this angle, the fact it's supplementary with the 80 means it would be 100. I don't need it though, I need x. It's 30. For number 6, I'm going to take this radius and rotate it down and put it here, such that now I have a right triangle with a hypotenuse x, a leg that's 8, and the other leg, which is half of that, 30, or 15. So that gives me that x squared equals 8 squared plus 15 squared. X squared equals 64 plus 225. That gives me x squared equals 289, which is x being 17. For number 7, I get that angle PLM right here is 42. I need MNL, which is back here. Now, a few ways we could do this. If I notice triangle PLM, this triangle here, it is isosceles because that is the PL and PM are both radiuses. So this is 42 and 42. Add those together, that's 84. 180 minus 84 gives me 96 for the central angle. Now that the central angle is 96, the arc is 96, LM, And now that I have that arc, I can take half of it and get my inscribed angle. 96 divided by 2 would be 48 degrees. For number 8, I have that WY is tangent to the circle, okay, and then TWY is 74. I need to find WPT. So I'm looking for the major arc. Two ways we could find it. The first way is I could take this 74 and double it to find this arc. So that arc would be 148. Then take that 148, subtract it from 360 to find what's left over out here. Before I do that, let's also look over to this angle over here. If this is 74, on this line, these two angles are supplementary. If I subtract that, I get 106. And then repeating the same process we did before, I can double that 106 and get 212 for WPT, as well as if I did 360 minus 148, I would get 212 as well. So that's our answer, C. Number 9, I need to find the value of x, and that's my angle outside the circle. Our rule for that is x is equal to the big arc minus the little arc divided by 2. This would be the little arc, this would be the big arc. We'll label them. Now I know the big arc, I need to find the little. The way I'm going to find that is at 80, 152, and 74, and get 306, and then subtract that from 360 to find what's left over, and I get 54 degrees. So now it's 152 minus 54 divided by 2, which gives me 98 divided by 2, or 49 degrees. For number 10, we're going to use the angles inside the circle. And for that one, we're going to do that the angle, we'll just say the angle A, is equal to arc 1 plus arc 2 divided by 2. So I have a top arc and a bottom arc. Well, really, when I solve this here, I'm going to be actually solving, let's call that y real quick. Either of these angles. Either of them are y because they're vertical to each other. That's what I'm actually going to solve for first. Then once I have that, I'm going to subtract that from 180 and find x. So 196 plus 92 divided by 2 will give me y. If I add those together, I get 288 over 2, which gives me that y is 144. Oops, ran out of space there. Move it up. Y is 144. Now to find x, I want to supplement to it. So I'm going to do 180 minus 144, and I get 36 degrees. Okay. Next, we go to number 11. We need to find the length of MA. So for this, we're looking at secants, a relationship for secants. And when we talked about secants before, we're going to do the entire secant times the external equal to the entire secant times the external. So let's just call this x for now. That's what we're solving for. So the entire top secant is 14 times the external is 6, and then the entire is x plus 7.
Students who are not participating in an extracurricular activity at this time, please report to the front of the school to wait for your ride.
It'll be x plus 7 times 7, because that's the entire thing times the external. That then gives me 84 equals 7x plus 49. If I subtract 49 from 84, I get 35 equals 7x, so x is 5. We know that's 5, and that is MA, which we were looking for from the beginning. For number 12, we need CD. That's actually a diameter here. Let's just call that x for the sake of it. For this one, I have a tangent and a secant. For this one, it's tangent squared is equal to the entire secant, kind of like above here, the entire secant of x plus 6 times the external of 6. That gives me 144 equals 6x plus 36. 144 minus 36 gives me 108 equals 6x. I then divide 108 by 6, and I get 18 for CD. For number 13, I have that UP is 2, NP is 4, UW is 18. Now, if this entire length is 18, that means this length from P to W is 16. If I need to find LP, this is where I have segments inside the circle. I multiply the segments of the same chord. So for UW, I would do 2 times 16 is equal to 4 times x, when that's the x value we're looking for. 18 is just the total of it. We have to find that 16 from it. That gives us 32 equals 4x. I divide by 4 and I get x equals 8, and that is LP, so B is our answer. For number 14, I'm looking for angle PAM. Now, I have this 156 here, and that actually goes to this inscribed angle, so I could take half of that and have that at 78. But what this is really testing us on here is, do you notice how PM goes through the center of the circle? That gives us a diameter. Now when we have an inscribed triangle where the diameter is one of the sides of the triangle, it tells us it's actually a right triangle. So angle A would be a right angle, which is also angle PAM. So that's our answer, 90 degrees. Now, if you also needed to find angle M or PMA, you would do 90 minus 78, and it would in fact be 12, and we could also go find the arc AP also there. But here it's really saying, inscribed triangle, where a side is the diameter, it's going to be a right triangle. For number 9, we need to find the area of the shaded region. So this is like that length problem we had, but this area is going to be the measure of the angle over 360 times the area of the entire circle. We ultimately have this fraction because that's going to tell us what fraction of the entire circle we want. So, right angle there, that tells us 90 over 360 times pi 8 squared. 90 over 360 is 1/4, and then we want 1/4 of 64 pi. 64 pi is the entire circle. We want 1/4 of that, so that is ultimately 16 pi. And that's millimeters squared. Let's not forget the units. For number 10, same idea as number 9. It's going to be the area is equal to the measure of the angle over 360 times pi r squared. We need to make sure we pick the correct shaded region. 220 is all of this. We don't want that. We want 360 minus 220. We want the 140 degrees. So make sure you're clear on that. Find that shaded region. So it's 140 over 360 times pi 9 squared. Well, 140 over 360, I can cross out the zeros. Gives me 14 over 36. I can take half of each of those, and that gives me 7 over 18 times 81 pi. Not as neat of a fraction here, 7 over 18. I mean, 1/4 is more common. We'd all agree for that. But we want 7/18 of the whole circle. It's the same idea. We will want what fraction of the entire area do we want. We could actually reduce this, 81 and 18. We can each divide them by 9, and that gives us 7 times 9 pi over 2, or 63 pi over 2 units squared. If you didn't see that, you could ultimately just multiply 7 times 81 and then have to reduce anyways, but we should get to 63 pi over 2. Number 11, we have, let's see, our measure from A to B is 16 pi over 3. We need to find the radius. So we go back to, let's slide up here, this problem right here. The reason how this problem differs is we get this value to start with, we get the angle, we have to figure out our radius. So we're just kind of solving it backwards here. So our length is equal to the measure of the angle over 360 times 2 pi r. An extra paper here, we're out of space. So Our length, we said, is 16 pi over 3. The angle is 80 over 360 times 2 pi r. The nice thing is this is in terms of pi. We don't have a decimal here, so it's going to be a little nicer to clean up. I get 16 pi over 3 equals, well, 80 over 360. We can cross out the zeros. I can divide both of those by 4, and that gives me 2/9 times 2 pi r. This becomes, on the right side, 4 pi over 9 equals r. We're going to basically move this over. The way we're going to move this over, we can multiply by 9 and then divide by 4 pi, or you could multiply by the reciprocal of it. If we just go one at a time, I'm going to multiply by 9, and then I'm going to divide by 4 pi. That gets us to r. I cross out the pi's here. I cross out 9 and 3. I can reduce 16 and 4, and it looks like we get a radius of 12 when all's said and done. So that's answer B. And a lot of that is just getting that set up and then solving with your algebra skills. Now for number 17, I need to find angle AGH. Now this angle matches up to this arc. But this arc also matches to this angle. So we've actually talked about these two angles are therefore the same. So our answer is 52. But maybe you didn't see that at first, and that's okay. We could take that 52, go to this arc, which is 104, then see that this arc matches to that angle, divide it by 2, and we get 52 from there. Now for 18. B and C are tangents, and we need to find BDA. Now, we have the rule here that we can do the big arc minus the little arc divided by 2 to get that angle, and we could solve here, but that would actually be a lot because, and if we called this x, this would be 360 minus x, and it may get a little complicated. We mentioned in the very first problem we did, though, that if we draw tangents here, we know these are right angles. Now, that gives us a kite. These are both 90, meaning this 43 and this angle are supplementary, which I get 137, which it's a central angle, so this arc is 137. Now when I need to find BDA, it's really the arc 360 minus 137, which gives us 223 for our arc, BDA. Number 19, we're given that TR is 110. We need to find TS. Well, notice that TR and RS are chords that have the same length. That means their arcs have the same length, so RS is also 110. I have 110 plus 110 is 220. I subtract that from 360, and I get 140 degrees for TS, which is the answer we're looking for. That's what's left over. In number 20, we're looking at GMJ is 220 degrees all the way around here. Now, KM is the diameter. That actually cuts it in half, the circle in half. So 220 is actually cut in half also, so we know that this is 110 as well as this is 110. Now on this left side of the circle, I have 110 already, which leaves 70 up here, and we'll also get 70 up there. So now I've actually filled them in. I can find the parts that I need. GK is what we found, 70. JM would be 110. Now for 21, this is where we have segments inside the circle. I multiply them. I get 5 times x plus 10 equals x times x. Gives me 5x plus 50 equals x squared, which actually becomes, if I move everything to one side, x squared minus 5x minus 50, which is now x by factoring, looks like x minus 10, x plus 5. And that's using some of our algebra skills from last year. And in this case, I need to find the solution that is positive. If x minus 10 times x plus 5 equals 0, my actual solutions are 10 and negative 5. But I can't have a negative, so it's not going to be negative 5. We will use 10. Now, for 22, let's see if we can get it on the screen here. 22, we have circle is inscribed in a quadrilateral. We have some values for A, B, and C, D. We need to find the perimeter. Now, what we notice here, and what it's really using, is not the fact that it's a quadrilateral, but notice that all the points A, B, C, and D have common tangents going to the circle. I have common tangents here, 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 and here. So, if this is 4, so is this. If this is 6, so is this. Now, I know that AB is 12, so this total length is 12. Well, that's already 4, so that must be 8, which is also here. CD is 13, so that's 6. That leaves 7 more. Fill that one in. So, I can fill in all those values. Now, I get the total length of my sides are 12, 10, 13, and 15. Then to find the perimeter, I add those up. And I get that the perimeter is 50 units. But that's using, again, common tangents, and common tangents are congruent. Move up here. Area of our shaded region is 27 pi over 2. We need to find the measure of the angle. So we go back to our formula here, and it's going to be the area is the measure of the angle over 360 times pi r squared. We figure out what we know. We know the area. We know the radius. We're solving for the angle. So let's say 27 pi over 2 equals, let's just call the angle x, just to make it a little nicer value to solve for, times pi times 6 squared. We get 27 pi over 2 equals x over 360 times 36 pi. I can write, let's see what we should do first here. Let's move it up here. 27 pi over 2 equals, let's call it 36 pi over 360 times x. And that's just rearranging it together. Now I can reduce this. 36 over 360 actually becomes 10, or 1 over 10. So now I actually have pi over 10. If I multiply by the reciprocal to the other side, the 10 goes on top, the pi goes on the bottom, and that gets x by itself. Now I can reduce, cross out the pi's. I can take 10 over 2 and make that 5 over 1. So ultimately is 5 times 27 gives us that our angle originally was 135 degrees, which again was the measure of MPN. So put that right there. So we have two tangent circles inscribed in a rectangle. The width is 12 and the length is 24. We're going to find the area of the rectangle, and we're going to subtract 2 times the area of the circle. Since they're the same circle, we just need to find the area of one of them and just double it. So our rectangle is 12 by 24. Since 12 is this width, that's its diameter, which means our radiuses are 6. So the area for the rectangle, 12 times 24, gives us 288 centimeters squared. The area for our circle is pi times 6 squared, or 36 pi. So we're going to do rectangle minus 2 times the areas of the circles. Gives me 288 minus 2 times 36 pi, or 288 minus 72 pi, and that is centimeters squared. That is in terms of pi, and that is an acceptable answer for us.
For 26, we need to find the area of the segment. So the segment is going to be the area of the sector, which is that slice we have, minus the area of the triangle. So looking at the sector we have, there's a right angle here, which tells us that our angle over 360 times pi r squared, we're going to do 90 over 360, times pi 10 squared. 90 over 360 is 1/4, times 100 pi, we get 25 pi. Now, for the triangle, if we look at it a little more closely, in this triangle we have a 10, since that's the radius, this side is also 10, and it's a 45, 45, 90. So really if they just gave us the 45-degree angle only, we would know it's a 45, 45, 90 because the two sides are the same. So in this, the area of the triangle is 1/2 base times height. The base is 10, the height is 10, so we get 1/2 of 100, or 50. So now the area of the sector, and we can just write this in terms of pi, not the sector, the segment, we should say, is going to be the area of our sector, 25 pi, minus the area of our triangle, 50, and it was centimeters squared.
Okay, now we shift gears and we're going to worksheet 7, and this is a good review looking at different angles, different angle problems as we go through it. So, for the first one, I have an inscribed angle with the 26. The inscribed angle to the arc, I double it, make this 52, and now that I have 52 here, I want x. Well, the fact this is a diameter, I take 180 minus 52 to give me this value left over, which is 128. For number 2, I'm going to take 210, 82, add those together, and that comes out to be 292. If I subtract that from 360, I get 68 for this arc, which is left over. Then to find the angle, I take half of it, and it's 34 degrees. For number 3, I have the arc is 82. I need x. Oops, move over here. Arc is 82. I need x. To get the inscribed angle, I take half of that, and it is 41 degrees. The central angle right here would be the same, but the inscribed angle is, in fact, half of it. For number 4, I have 280 is this arc. And we've kind of seen one similar to this earlier. To find the angle that goes with the 280, I take half of it. So this would actually be 140. I could then find the supplement next to that to find x, which is eventually 40 degrees. Or I could have taken this 280, subtracted it from 360, and found that this arc would have been 80 degrees, taken half, and gotten 40. Either one would have gotten you there. For number 5, I have 190 plus 20 is 210. 360 minus 210 is 150. That's the amount for this arc and this arc together, but since they have the same chord, we know that they're equal. I divide 150 by 2, and I get 75 for each of those. Number 6, I have the inscribed angle is 64. I double that, and I get 128 for its arc. Now I know that these two arcs, the one that includes x and the one on top, are the same. I take 360, subtract it from 128, or take 360 minus 128, I should say, and I get 232. I then divide that by 2, and I get 116 for both of those, and that's because 232 divided by 2 is 116. For number 7, I'm first going to solve for, let's call this angle y here, the one next to the x, because these line up. The arc, or the angle, is equal to the arcs added together divided by 2. That's 140 divided by 2, or 70. Now that I have 70, I need to find the angle next to it. It's supplement. 180 minus 70 gives me 110 for x. Number 8 is going to follow the same process. This time the angle 73 is equal to x plus 64 divided by 2. I'm going to multiply over by 2 and I get 146 equals x plus 64. I then subtract 64 and I get 82 equals x.
All staff, please post your attendance. All staff, please get me your rosters, and if anybody covers anybody else's class, please get me their attendance. Thank you.
For number 9, I have 100 degrees for this arc, 200 degrees for this one. Together, that's 300 degrees, which leaves us 60 degrees here. Then to get this 60 degrees to match to this angle, it's an inscribed angle. I take half of it, so 30 degrees is my value for x. For number 10, I need to find the big arc minus the little arc divided by 2. So big minus little divided by 2. I need to find this arc first, so I'm going to take 95 plus 68 plus 167, add those together, subtract them from 360. It turns out to be 30 degrees. So I'm going to say that x equals 68 minus 30 divided by 2. 38 divided by 2, which is 19. Then on number 11, it's going to be the same process. I know that this arc is the same as this one because their chords are congruent, so that's 100. 100 plus 100 is, or plus 90 is 290. Subtract that from 360, I have 70 left over. That's my little arc. So x is equal to big arc minus little arc divided by 2. 20 divided by 2, or 10 for x. Zoom out a little bit. Okay, for number 12, I'm going to use the big arc minus the little arc divided by 2 equals the angle to first find this one. Once I have this, I can then add that to the 170 to the 90 to find what's left over for x. So 29 equals, let's call this y here, 90 minus y divided by 2 gives me 58 equals 90 minus y. I then get negative y equals negative 32, which means y is 32. Now that I have that, 32 plus 170 plus 90 is 292. I subtract that from 360, and I get that x is 68 degrees. For number 13, I'm going to need to first find this angle, or this arc over here, y. Same process. It's going to be 35 equals y minus 80 divided by 2. That's 70 equals y minus 80. 150 equals y. And now that I have that, I know 150 plus 80 is 230, which leaves me whatever 360 minus 230 is for x, and that turns out to be 130 degrees. For 14, I'm going to take 360 minus 285 to find the inside arc. 360 minus 285 is 75. So now x is equal to 285 minus 75 divided by 2, or 210 divided by 2, which is 105. Now for 15, I'm going to take this angle, add the arcs, divide by 2 to solve. So I'm not really solving for an angle now, I'm solving for x. This becomes 72 equals 10x plus 14 divided by 2. From this point I have two options. I can multiply over the 2, or the fact that 10x and 14 are both divisible by 2, I'm just going to divide them and get 5x plus 7. This now comes by subtracting 7 to be 65 equals 5x, so x is 13. For 16, it's going to be multiplying the product of the segments. I get x times x equals 5 times 10. X squared equals 50. X equals the square root of 50, which we simplify to be 5 root 2.